Kia ora Year 12. I've had a couple of you finish off assignment 2 and let me know that you're ready for some solutions, so I thought I would video these this week. So this one is based on the 2018 papers, and there are a mix of questions here. There are a few merit questions and there's one excellence question. So I'm not going to go all the way through that excellence question because I'll probably run out of time, but you can see here there are links to where I've done that video separately. Okay, so let's start off with the 3 calculus ones. The first one is very similar to what we had last week. It's the usual pattern. We're given a function and we have to find the gradient of the graph of the function where x equals 4, right? So we know that this is a cubic with a positive coefficient, so it's an up, down, up pattern, and we're looking for the gradient where x is 4. So all we have to do with that is differentiate it. So we start with f of x. So f of x is equal to x cubed minus 6x plus 2. F dash of x is 3x squared minus 6. And now we need to substitute in f of 4. So that gives me 3 times 16 minus 6, which is 42. And not surprisingly, that's an achieved question. Okay, let's look at the next one. Now, the next one is from rates of change, which some of you did really well and focused on when you were working through the Walker books, and some of you not so much. So now's probably the time to go back over that. We're told we've got a rectangle, and for some weird reason, it's expanding in area, so that all the time its length is going to be 3 times its width. Find the rate of change of the area of the rectangle with respect to its width. So we want our variable here to be width, which we'll call w, and we're finding that rate of change when the rectangle is 75 centimeters squared. So I've already videoed this question, but I'm going to do it quickly in here. This video will have me going through it more slowly. Okay, if you can't find it, just go to the playlist for the level 2 external exams. So we'll start off by saying let the area equal the length times the width. And then we know that the length is equal to 3w. We have to have this because if we want to differentiate, we need to just have one variable. So a is equal to 3w times w, which is 3w squared. And we're asked to find the rate of change of area with respect to the width. So that means we're differentiating, and we get 6w. And the question asked us to work out what that rate of change was when the area of the rectangle was 75 centimeters squared. So if the area is 75, we need to go back and say what was the width then. Okay, so we're solving. A equals 75, 3w squared equals 75, giving us w squared is 25, which means that I get w is equal to 5. Now I have to take that width value and sub it into here, right? So dA by dW is equal to 30, and I don't have to have my units to get the marks, but I should really. So it's 30 centimeters squared per centimeter, right? That top number is the area unit, and the bottom number is the width unit. So there you go. So that's a merit question. Once you get the hang of those, they're actually reasonably easy. You always want to start with having your formula, and then you need to reduce it to functions of one variable. Okay, next one is also a merit question. So we're given a derivative, so a gradient function, right? So the derivative of the function is given by f dash of x is equal to all of this, and the graph of the function has got a local minimum at this point here. And so we have to use calculus to find the x and y values of the local maximum. Now, we know that we're going to have a local maximum and a local minimum when this is equal to 0. So I can start this question in one of 2 ways. I can either figure out the x values that will give me f dash of x is equal to 0, and we know that one of them's x equals 0. Or I can start by anti-differentiating this because I'm going to need to have f of x in order to get the y value. Okay, so again, I've videoed this separately already, but just doing it again. Here's f dash of x is equal to negative 3x squared plus 12x. Now I'm going to start by anti-differentiating because I'm doing a calculus exam, and so I like to do some calculus pretty early. So f of x is going to equal negative x cubed plus 6x squared plus c. And we know that 0, 5 is on the curve. So we can sub that in. We get 5 is equal to 0 plus c. So that gives me f of x is equal to negative x cubed plus 6x squared plus 5. So that tells me that once I figure out where the x value is for the maximum, I'm going to substitute it into that function. So let's now do that second part. So for a max or min, we have f dash of x is equal to negative 3x squared plus 12x must equal 0. So we can factorize this to solve this little quadratic. We'll have negative 3x as my first factor times x minus 4 for my second. So x equals 0, which we already knew, or the other one, x is equal to 4. So let's look at why that makes sense. This is my function, and its shape isn't a down, up, down cubic. So here's my first value, which is x equals 0, and here's my second one, which is x equals 4. So that's going to be my maximum. All I need to do now is to take that x equals 4 and substitute it in to the function, right? So f of 4 is equal to this, negative 4 cubed, 64, plus 6 times 4 squared, 6 times 16, plus 5. Right, so that equals negative 64 plus 96 plus 5, which gives us 37. So that's that question done. Okay, on to a couple of easier ones. We'll do some algebra ones now. So this simplifying one, I'm just going to do here. So this equals 25 to the power of 1/2, which is the square root of 25. And then all I have to do here is multiply my powers together. So it's 5m to the power of 8. Right, so for once there's a question that you don't need to show any more working for than that. Right, so that's a U question. This next one, write this as a single fraction in its simplest form. Okay, so we've got 4 minus b plus 8c over 3c. Now the first thing to do is to put your invisible brackets in there. Right, and then the second thing to do is to get a common denominator. Now some people have written that as 4 over 1, which is quite a good way to jog your memory that we have to find a common denominator from these. So the common denominator here is going to be 3c. Right, what did I do to the 1 to get to 3c? I times it by 3c, so that's what I have to do to the 4, giving me 12c. And then here, I didn't have to touch this, so it's still minus b plus 8c. Right, but we've got to write it as a single fraction, so it's going to be this, 12c minus b plus 8c, which gives me 12c minus b minus 8c over 3c, which is 4c minus b over 3c. So there you go, that's your final answer there. Right, question, what are we up to? Question 6. Oh, this is a completing the square one. I've had a couple of you tell me that these have got much easier since you went and watched this video. We started looking at these again in last week's assignment 1. So the way that I do these is I box up this first bit here. So f of x is going to equal x. And then I think, what will get me the plus 6x? I have to halve that 6. So it'll be x plus 3 squared. But now this would expand to give me x squared plus 6x plus an extra 9. I undo that 9 and I have the plus 5 that I had to start with. So we end up with x plus 3 squared minus 4. Right, if you weren't clear on how to do that question, I recommend this video here, at least the first bit of it. I've done some harder examples in it from a class a couple of years ago, but it's a good starting place. Okay, question 7 is what we call factorizing by grouping. And this video, again, goes through it with lots of examples, but I'm just going to do this one here, and I'll do this on a new page. So we've got 4b, where's it gone? Where's my question? 4bx plus 2xy minus 6ab minus 3ay. So when I look at that, it looks horrible. There are 4 variables. But again, I take this method of just worrying about the first 2 terms and looking at a common factor in there, and then hoping that something's going to fall out that's similar in this bit here. So for these first 2 terms, look at my numbers first. The highest common factor is 2. Look at my b's. Have I got a b here? No, so b's not it. Look at my x's. I've got x here and I've got x here. So it's 2x, right? 2x times what will get me all of this? 2x times 2b. Right, 2x times what will get me all of this? Plus y. Now we do the same thing on this one, and we're going to hope that that 2b plus y pops up again, and it does. So here we've got the numbers. We've got highest common factor of minus 3. We've got a here and we've got a here. So we've got a common factor of a, and then we've got 3a times 2 to get the 6, 2b plus y. Right, now let's see what we've got. Well, we've got a common factor of 2b plus y. So that's 2b plus y times this, 2x, minus 2b plus y times 3a. So there we go, we've factorized that, and I'm going to expand that so that you believe me, right? So let's just expand it out again. Don't expand it out if you're answering the question. That is your final answer. But we can see that we get 4xb plus 2xy from here, minus 6ab minus 3ay, which is what we started off with. All right, this video is already 11 minutes long, so I'm not going to do this excellence question. I'm going to show you how to start it, but I want you, if you're thinking about having a go at it, please go watch this video where I do it really slowly. So the thing here is we've got a rectangular box with no lid, and you have to turn these sentences into equations. So we know that the length is 60, and we're told something about the height. And we can also see we've got the width. And we have to work out the area of the base and the 4 sides. So we can start out by thinking that the area is going to have the base, which is going to be this surface here, which is 60w. And then we're going to have these 2 sides here, which will be 2 times w times h, 2 because there's 2 of them. And lastly, we're going to have 2 of these sides here, which are going to be 60 times h, right? And we know that that area, and we don't have a lid on the box, so the area is going to be 7,400. So we're setting that equation up to start with. And then we can also see we've got this link between height and length. So the height is 1/4 of the sum of its width and its length. And we're going to take that expression for height and substitute it into these places here. So that should be enough to hopefully let you see that this question is extremely doable. So go watch that other video from me going through it. Thanks for watching, and I will see hopefully most of you online in a couple of hours.